Section 2.4 is called average rate of change. And if I say average rate of change, anything come to mind for you? Slope, good. Slope is an expression of average rate of change. Rise over run. If I am driving to Albert Lee from Owatonna in the morning, and I travel at a speed of, we're wondering how fast I'm going, but I get here in half an hour, okay? And I drive 35 miles. Well, I could take 35 miles divided by 1/2 of an hour, and you would see that my average speed is 70 miles per hour, okay? And some people said, well, you must be speeding in the middle there then. Well, we'll talk about that in a second, but that'll be my average rate of change. My average rate was 70 miles an hour. So we like to express this using a graph. It's my y-axis, my x-axis. Draw something that looks like this. This will be my function, f of x. And when we find average rate of change, we find it over a given interval. So for example, the interval for this morning for me, and generally each morning, is from 7 o'clock, I leave home, and I get here at 7:30. Okay? That's generally the interval with which we're trying to find find average rate of change. So in this situation, we're going to start at A. That's the beginning of the interval, and we'll end with B. Does anybody know if this is f of x and this is A, what would be my y value here? If this x value is A and this function is f of x, what would my y value be? F of A. I would plug it in, and whatever I would get would be my y value. So what would my y value there be? F of B. And that represents the average rate of change if we were to find the slope. Namely, the slope of this line we will refer to that later in calculus as the secant line. Secant line touches two spots. That's the average rate. Now, let me ask you a question here, okay? If I leave at 7 o'clock and I get here at 7:30, my average rate is 70 miles per hour. True or false? Sometime between there, I'm traveling less than 70 miles per hour. True. If I'm traveling less than 70 miles an hour sometime between here and my house, and my average rate is 70, then at some point I must be traveling greater than 70 miles per hour. True or false? True. So a cop could pull me over for speeding if I actually got here at 7:30, because he could say, well, in order for that to work out and not speed at all, you'd have to be going 70 miles per hour from the time you left your house to the time you got here. And that's just absurd because you got stoplights and everything else. You could say, I imagine you're going a little bit faster, and all of a sudden he slaps me with a ticket. So the fact is that is true. And if you look here, if you look at the beginning, if the slope of this red line represents the average rate of change of that function, at the beginning, I might be headed at a greater rate. And at the end, I might be headed at a less of a rate. Okay? So average rate. How do we define it? We define it like this. Average rate of change equals delta y over delta x. Delta looks like a triangle. It's the Greek letter for D, capital D. Okay. Small delta looks like this. Capital delta looks like that. Okay, don't need to memorize those. But change in y over change in x. What does that look like? Well, you guys are used to seeing it like this. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Which you've always said is the same thing as your slope. Which you're right. But that's the same thing as what we're going to do now is, according to this drawing up here, what's my second y value? F of b minus f of a divided by b minus a. And that's how we'll define average rate of change. Nothing different than slope, but we're going to apply it here in a second and do something interesting with it. Any questions before we try a problem? Okay. Let's try this problem. Okay, example 1. F of x is x squared plus 2x minus 5, and we're going to find the average rate of change from -1 to 4. We're going to find the average rate of change from -1 to 4. If I want to find the average rate of change, I identify A and B, F of A, and F of B. A for the day, what's A in this situation? -1, what's B? What is F of A? -1 squared is 1, minus 2 is -1, minus 5 is -6. So -6 is my F of A value. F of B, I would plug in 4. 4 squared is 16, plus 8 is 24, minus 5 is 19. So I have my 4 values, and now I can simply plug it into my formula for average rate of change. F of B, which is 19, minus F of A, which is -6, divided by B, which is 4, minus A, which is -1. You can see we will add the opposites. 25 over 5, which is 5. That's my average rate of change. Any questions? Simple? Okay, take out your graphing calculator. Let's go to our graphing calculator, and as you look at it, we have x squared plus 2x minus 5. We'll let you type that in quick. And I know that my x values are going from -1 to 4. So my window, I suppose if I made that, -3 all the way up to, say, 6, that'll be plenty of room to see my x values, right? And then my y values were as low as -6, and they were as big as 19. So my y values, I'm going to go from -10 to 20. And I should definitely see a nice picture of the graph. What are these XSCL things again? Scale, that's the number of tick marks you're going to have, or how often they're going to occur, excuse me, how frequent. So I can look at that, I can press graph, and there's my shape. It's a parabola, right? If you were to go from -1 up to 1, 2, 3, 4, up to 4, if you were to connect a line right there, does that look like it could be a slope of 5 possibly? Yeah. So I'm just saying you can look at your calculator and just get a reasonable solution to whether or not it's accurate. In fact, if you want to go to your table, you could type in -1, you can type in 4, and make sure your values are correct. 19 minus -6, and 4 minus -1, and you could go from there as well. Any questions on that? Okay, please, before we do the next example, please open your book so we can look and see exactly what we're doing today. Open your book to page 182. As you look at page 182, like problems 1 through 6, you're given a function and you're given an interval. Could you do the problems we just did? Okay. Please look at 15 through 18. See how they have the pictures? They don't give you the function, they don't give you the they don't give you the values. So how would you do those? Just count the boxes. You're just finding the slope, okay? The slope of that segment. That's all you're doing, okay? That's all you're doing. So if I ask you to do 1 through 6 and then 15 through 18, you're okay with that? Okay, then let's do something so we can do 13 and 14. Let's try another look at this, okay? Example 2. We're going to do -3x plus 6. We're going to find the average rate of change of that. And we're going to do it over the interval a to a plus h. Now, the reason why we're doing this is so that calculus next year will be easier for you. Okay? So I want you to understand this piece. Now, let's make a little sketch just like we did before. We'll call this y. We'll call this x. And we'll call this f of x. And I have my first point. My first point is A. You tell me, what is my y value? F of A. My second point is A plus H. So my y value would be f of a plus h. Does this look familiar? We did examples like this, right? We plugged in stuff like this. Well, maybe it doesn't look familiar now. Maybe it will in just a second here. If I wanted to find the average rate of change to represent the slope of that black line, I would take my second y value, f of a plus h, minus, what's my first y value? F of a, all over, what's my second x value? A plus h, minus, what's my first x value? A. Look at the denominator. What happens? Yeah, your a's go away. And you can see that you're left with this expression. F of a plus h minus f of a all over h. Does that look familiar? We did this in section 2.1. We did problems. Remember, I had you set them up. We tried the one part, we tried the other, then we put it all together. Which is why we're going to review on, tomorrow. Tomorrow we'll do the review game. That way you guys will catch up with some of the stuff. So this is it, okay? And this represents the average rate of change. Now, I want you guys to understand where this comes from. Look it up here. Do you see that in calculus? It says f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h. That's kind of what we're doing. But watch this. And your book wants you to see a little bit of it so you know what you're doing. And I'm almost done, then we'll do the problem, okay? You don't have to set this up every time. This is just kind of show you what's happening. Who can tell me what the distance is between a and a plus h? H. So, just pause, just think about this for a second. We are finding the average rate of change between 2 points. In calculus, we find the instantaneous rate of change at 1 point. We don't need 2 points for slope, we just use 1. So watch. If I want to use 1 point as opposed to 2, I'm going to take this point right here, and I'm going to bring it close to A. I'm going to bring this close to A. As this point gets closer to A, what happens to H? A what? How small? It gets very, very small so that if you were to approximate it, how small would it get? How about this? Andy, if I put A plus H right on top of it, what would H be? 0. The distance would be 0. Look. Look. See? What do? Look at the problem. In order to make this H go to 0, we use this idea of limits, which was developed by Archimedes way back when. And we push that H to 0. That's exactly what we're doing. And so what you're doing right now is the very first introductory piece to what you would see in calculus. Only you need to know how to deal with limits, but you don't know how. There's one piece, though. So we won't do the limits piece, but just think about this for a second. One last piece, and I promise I'll move the problem. Let's suppose that H was actually 0. Can you have a 0 in the denominator? So that causes a problem. Let's do the problem. Again, the problem is f of x is equal to negative 3x plus 6. Is that what I have? Plus 6. And we're going from a to a plus h, and we want to find the average rate of change. So I need to do the first part. What is f of a plus h? What is f of a plus h? Negative 3 times a plus h plus 6. Okay, that's my f of a plus h. So I plugged that in first to here. Okay, so I took this and I plugged that in. That's what I first did. Now I'll do the second piece. What do I get if I plug that in? So minus negative 3a plus 6. Okay? And then I divide the whole thing by h. So I got to simplify that. What do I get on top? Negative 3a minus 3h plus 6 plus 3a minus 6 all over h. What cancels? Minus 3a plus 3a plus 6 minus 6. That gives me negative 3h over h. What's negative 3h divided by h? Negative 3. What? Oh, yeah. Like that? My answer is -3. I want you to think about this, and then I'll give you your assignment. Look at this function. If I were to graph this, what does it look like? A line. What is the slope of a line all the time? Of this line in particular? -3. Are you surprised that you came up with -3? No. Okay. But for other functions, it would be different. But in this case, yeah, -3 is what we want. And so some people said a second hour, they're like, well, Mr. Gens, we knew that the slope was -3. Well, did you? Had you ever proved that the slope of a line over any given interval is actually m for y equals mx plus b? Well, now we did. Okay, now we've shown it. So, page 182, numbers 1 through 6, 13 through 18, section 2.4. Tomorrow review game, I'll give you a study guide. Wednesday is all day study guide, and Thursday's test.